The bottom part of page 4 of your notes, and this is on cell potential, your voltage, versus K. So we did cell potential versus delta G, cell potential versus K here. So let's relate all three of those things together in this case. This is called the Ratlink equation, by the way. So negative RT ln K. There's your R value. So you can relate delta G to that. So you got about 3 different delta G equations then that you can use in this stuff. So if you write this stuff, if you have a positive cell potential, it means you have a negative delta G, which means you are spontaneous or thermodynamically favored. And that means that your K value, if you remember delta G versus K, your K value then is greater than 1. Your equilibrium constant is greater than 1. So positive voltage means we have an equilibrium value greater than 1. The forward direction of the reaction does want to happen from there. So this one, figure out the K value for the following reaction: HCl plus zinc, forming ZnCl2 plus H2. So we have, essentially we can get rid of the chlorine. So we really have H plus here and Zn plus 2 there. So we figure out our potential of our cell. We have H plus going to H2, and that potential, reduction potential, is 0 volts. And then Zn to Zn plus 2, that's oxidation. That oxidation potential, again, this is just off your chart, is a positive 0.76 volts. So there, add those two together, and that is our cell potential then of that. So if we want to figure out the K value here, we can plug in, again, I didn't leave a whole lot of space, so we can plug this into delta G equals negative N F E of our cell. So we can plug that in for our potential of our cell. And then we can take that and plug in for delta G into the Ratlink equation. So
Shea Hernandez and Aaron Betts to the attendance office, please.
296, 485, 0.76. Hey, hold on for a second. Close that, would you? Hang on for 1 second. So get your delta G there. Delta G is negative 146.7 kilojoules. Now I can take that and plug that into delta G equals negative RT ln of K. So our K value is our equilibrium thing there. So we can put negative 146,700, because our R value is in joules, equals negative 8.31 times our temperature in Kelvin, which is 298, times the natural log of K. So we need to multiply these, divide the other side, and we're going to end up with some number equals ln K. Hit second function, ln of that number. I got a K value of 5.3 times 10 to the 25th. Huge K value, meaning that reaction goes to completion in the forward direction. Negative delta G means it's spontaneous, bigger than 1. Okay, positive cell potential voltage. Those all kind of go hand in hand.